Hola, so here we are going to go ahead and determine if the graph, table, or mapping diagram is a function. So the first things first is we have a definition of function right here. I want y'all to go ahead and read the definition yourself. Pause the video. Okay, so it says a function is a relation where each value in the first set, the input or x, is matched to exactly one value in the second set, the output or y. So for every x value, there's only one y value. So it can't be matched to the same thing. So for example, if I had a table and I had x is -1 and y could be 0. If my next value said then if x is -1, y is then 3, then this would not be a function because they can't have -1 match the same thing. The way that I like to remember this is really to think of it like it's a vending machine. So basically a function is a vending machine. It's a relationship you have happening. So friends, we all know this. When we go to the vending machine, if I push A2, what is supposed to happen? What's supposed to happen is I push A2 and I get, ahí está, tengo un Snickers bar. I got one piece of candy when I went to the vending machine. So a function is like a vending machine in that when I put in a value, an x value, I get out one y value. So when I put in A2, I get out just my Snickers bar. This is what a function is not. A function is not that when I push B3, I get out animal crackers as well as M&Ms. A function cannot have you put in one thing, for example B3, and get out two different things, animal crackers and M&Ms. I can't get out two values for y when I've only put in one value for x. So again, a function is like a vending machine. So pause the video and think to yourself, how is a function like a vending machine? Hola. Okay, so again, a function is like a vending machine. When I push one thing, I get one output, E4, hot Cheetos. Function is not when I get one input, D5, I get out two different outputs. Not what a function is. So let's look at some examples. The first example is on a graph. So on a graph, we know, hold on. Okay, welcome back. So on a graph, we're going to use the vertical line test. So basically, the vertical line test, and you guys make sure you have this notes page. This one right here, y'all should have this in front of you. This is where you're going to take your notes right here in these sections and draw the examples. So if you don't have those, they're in the plastic bin. You need to go get those now. So the vertical line test on a graph is basically saying we're going to draw a vertical line to make sure that when I draw the line, each x value only pairs with one y value. So if I take this, for example, if I look at this first graph, I want to decide whether it's a function or not. So your paper tells you it's a function. I know it's a function because y'all should be drawing this with me. When I draw a line right here, when x is 1, notice that I only have this one possible y value. When x is 1, y is only 1. If I draw a line over here, even in the middle of -1 and -2 at -1.5, I see that I've only crossed my blue line at one point, this point right here. So this shows me that this is a function because when I do the vertical line test, I only cross the line one time, meaning each x value only has one possible y. So go ahead and pause the video. Make sure you have your notes right here, the vertical line test, and write in your sentence in this blank space. So what is right here, we will copy, and you will put that in this blank here. You'll fill in yourself the first graph is or is not a function because of what. So pause the video now. Okay, I'm going to ask you to read me what you wrote when you come to me. So y'all should all have already written down your answer to this in here. You should have written in this box. I'm going to show you what I wrote. So I said the first graph is a function because when we do the vertical line test, each input has only one output. So when I drew my vertical lines, each x value only matched with one y value. So this second one is not a function. So I want you to think about why it's not a function. Pause the video now. Okay, the second graph is not a function because look at this. Bam! When I do a vertical line test, when I'm looking at x equal to 2, I have passed two different y values. So even though there's a relationship here, when x is 2, it has y values of 1.5 and negative 1.5, meaning it is not a function. If I do another vertical line even right here, I see that when x is 1, it also has two different possible y values. I crossed the blue line twice, so this is not a function. So pause the video and write your sentence for why the second graph is not a function on your notes page. Why is the second graph not a function? Okay, so let's read what I put. Remember, I'm going to ask you for what you put when you come to our group. I put the second graph is not a function because, whoopsie daisy, hold on. Okay, the second graph is not a function because when I do the vertical line test, many of my inputs, my x values, have more than one output, more than one y value. Let's move on to the table. So on the table, you only get to use one-to-one correspondence. So basically, you're just going to look and see, does each x value, these are my x values, have only one possible y value. So looking at this first table, I took my ordered pairs, my x's and y's, and plugged them into a table. I can see that this first x, negative 1, only matches with 3. There's no other negative 1s. 0 only matches with negative 4. 1 only matches with negative 7. So do y'all think this is a function or not a function? Function. So we're going to write our sentence off to the side so you can pause the video and write your sentence. The first table is a function because when we match each input value and output value, we see each x matches only one y. Go ahead and pause the video and write that down. Alright, looking at the next one, we can tell the next one's not a function. I want y'all to circle on this table. Why do you think this is not a function? Did you do it? Okay. So we're going to look here. We can see this is not a function. I know because I'm looking at x is negative 2. Notice that when x is negative 2, this says y is 1. But then later on in the table, x is negative 2 says y is 4. That means this isn't a function. I pushed on my vending machine x negative 2, and I got out two different responses. I got out negative 1, and I got out 4. That's not okay, guys. That means this is not a function. So we can say that this is not a function. Table number 2 is not a function. Why? So pause the video and I want you to write your sentence on your notes on why you think that's not a function. Do that now. Okay, here we are. Remember, if I'm talking too fast, you can always pause the video, rewind the video, rewatch whatever you need to. So the second table is not a function because when we match each input value and output value, we see that when x is negative 2, it matches the y value of negative 1 and of 4, which is not okay. So right now I want y'all to pause the video and go back to your notes. What I should see on your notes are sentences over here in these blank boxes right here where you filled in the blank. So your version of these sentences, including what you filled in, should be on your notes under graph and table already. The next one we're going to do is our mapping. So pause the video and make sure you have all of that before you move on to mapping. Alright. We're going to do mapping diagrams. Y'all have never seen mapping diagrams, and it says for a mapping diagram, do the arrow check. I like to call the arrow check the Katniss and Peeta check. Katniss and Peeta. Have y'all seen the Hunger Games movies? Maybe. So this is what I like to think about. Katniss is really good at her bow and arrow, right? She's like super awesome. So Katniss can do her arrow, and her arrow can go and it can hit the tree. This is what cannot happen with Katniss's arrow. Even though Katniss is awesome at her bow and arrow, Katniss's arrow cannot split into two separate arrows at the exact same time. It's not okay. So Katniss's arrow can hit whatever she wants it to hit, like the tree, but it can't split into two separate arrows. On the other hand, if Peeta came along, and we know, TBH, that Peeta is not as good at throwing his bow and arrow as Katniss. However, Peeta has a chance of shooting a different arrow and hitting the same target. It could happen. Even though he's not very good, it could happen. So when we look at a mapping diagram, we know this first one is always our input, and the second one is always our output. And I like to think of my inputs like I'm thinking about Katniss and Peeta. As long as each arrow, so each input hits a different output, we're okay. So when I look at this, I see that -7, sorry about that, -7 hits 2. Okay, cool. 13 hits 0. Okay, cool. 5 also hits 0. So I think back to Katniss and Peeta. -13 and 5 are different numbers. Katniss can hit the tree, and so can Peeta. I'm okay. So my first mapping diagram is a function. The reason it is a function is because each X input has only one arrow to an output, even though Katniss and Peeta both hit 0. So pause the video and make sure you have that sentence written down. Now, looking at this second one. This second one is not a function. Not a function. And we're going to think back to Katniss and Peeta. When I look at my input values, I see that Katniss here has some arrows. Katniss's arrows broke and hit multiple different targets. -3 hit -2, -3 hit 1, and -3 hit 0. Regardless of how good Katniss is, her arrow cannot split into 3 different arrows. So this is not a function. The reason it's not a function is because the second mapping is not a function because when Katniss threw her arrow, it split and hit 3 different targets. That means the input value of -3 has arrows pointing to multiple output values, -2, 1, and 0. Impossible. Katniss and Peeta can hit the same target, but Katniss cannot shoot one arrow to 3 different targets at the same time. It is impossible. Her arrow can only hit one target at one time. So pause the video and write that stuff down.